Okay, welcome to this video where we're going to continue to build on the foundations of geometry that we laid down in the last video. So the first term for today we're going to talk about is segment. A segment is the part of a line consisting of two endpoints and all points between those two endpoints. Look at an example here in green. Notice we've got a line, but then we've got just a segment in green. So consisting of two endpoints A and B, and then all the points in between them. Okay, so we can call that segment AB with words, or symbolically we can say segment AB. Notice we've got the two endpoints and a bar on top. Okay, real similar to the notation for a line, but notice the arrows are missing off the ends. Okay, or we can even call it segment BA. The 2 points, the order of the 2 points when you use symbolic notation doesn't matter when you're naming a segment, just like in a line. Okay, so keep in mind the importance of the symbols in geometry. We're going to be using these a lot this semester, and the subtle differences, like the arrows on this bar for AB, notating line AB, names a different figure than this one. This is segment AB, a different figure than line AB. Okay, so keep that in mind. Those subtle differences are important. Okay, next up, array. Array is the part of a line consisting of one endpoint and all the points of the line on one side of that endpoint. Okay, we've got an example here. We've got ray AB in blue. Notice that it's part of a line, but it's only the part on one side of a particular endpoint. In this case, we've got the endpoint of A, and B is just some point on that ray. Okay, so we can call that ray AB. Symbolically, we can say ray AB like this, where we've got kind of a combination of a segment and a line. We've got just one arrowhead pointing to the right. When we use this notation, we've got to make sure that we use the first letter is the endpoint, and the second letter is any other point on that ray. So if we had other points on this ray, we could use that in place of B. Okay, here's another example of array using the same line, but notice that this time our endpoint is changed to B. So we've got B and it's going in the opposite direction, where A is part of the ray. So we can call that ray BA. Remember, our endpoint has to be the first letter when we use symbolic notation. Okay, so ray AB will never be the same as ray BA in a particular diagram. Okay, so again, with ray BA, not the same as ray AB. And also when we use our symbolic notation, our arrow has to be going to the right. So we couldn't name this AB and then put the arrow to the left. It's got to be going to the right, even if on our diagram in the picture the ray is going to the left. Okay, our next term is opposite rays. Opposite rays are two collinear rays with the same endpoint. When you put opposite rays together, they look just like a line. So in this example, we've got ray EC and ray EF. Okay, EC starts at E, goes through C forever. EF starts at E, goes through F forever. Okay, opposite rays form a line. Okay, next up, we've got parallel lines. Parallel lines are coplanar lines that do not intersect. This is not a new term for you. You've seen it in algebra and middle school classes, but we might use it in different ways and in more detail in this geometry class. Okay, so notice that they're coplanar and they never intersect. So look at our diagram here, similar diagrams to the last video. We've got a three-dimensional figure. Again, keep in mind the dashed lines indicate that if this were a solid figure that you couldn't see through, those would be edges that you could not see. Okay, so a couple examples of parallel lines in this diagram. We've got line AB. Even though it doesn't show the entire line, it exists. Line AB is parallel to line DC. Okay, we use these diagonal slashes, or backslash, to indicate is parallel to. Another example, we've got line BF, this back right vertical line, and DH are also parallel. Another term, parallel planes. So planes can also be parallel. And They're planes that do not intersect. So any two planes in space that do not intersect are parallel planes. Again, looking at this diagram, we've got a couple of examples. Two examples are plane ABCD, so the top of our box, and plane EFGH, so the bottom of our box. Okay, those are parallel planes. They'll never touch. Remember, a plane goes on forever and ever in the flat directions. If you can imagine they're going on forever and ever, they'll never touch the bottom of that box. Okay, another example, plane BCG, the right side of the box, and plane ADE, the left side of the box. Okay, they'll never touch. They're parallel planes as well. And then of course the front and the back are also parallel. Okay, our last term, skew lines. Skew lines have 2 or 3 important characteristics. First one, they do not lie in the same plane, so they are non-coplanar. They also do not intersect, so they're similar to parallel lines, but they're non-coplanar. They're not parallel, we call them skew. So a couple examples, line AB, we'll start off with that one. One line that's skewed to line AB is line CG. You can see CG here is the vertical front right edge of the box, and AB. So they'll never intersect. They're skew lines. But they're also not in the same plane. Okay, another example, line EH, the bottom left edge, and line DC, the top front edge. Okay, you can imagine those lines going on forever and ever. They will never intersect as well. So those are skew lines.